Welcome to Learning Intention 3, Equation of a Line. In this video, we're going to have a look at graphing linear equations on a Cartesian plane. Now, the learning objectives for today are understanding how to interpret each member in a two-variable linear equation, how to sketch a linear equation in slope-intercept form, and finally, identifying an equation of a vertical and horizontal line. So part 3, in fact, all of these features carry on from Learning Intention 2 using the gradient. Now jumping in the subject matter today, consider that on the right hand side here, we've got this funky equation, r squared equals x minus h all squared plus y minus k all squared as well. Now you're probably asking yourself, what does this equation actually mean? And just thinking about it doesn't mean a whole lot to us. And the reason being is that it's actually quite a complicated looking equation. Now, if we go underneath the equation, what we can see on this Cartesian plane is there is a circle. And the reason there is a circle is because this circle actually relates to this algebraic mathematical model. So what we've got here are an algebraic equation and a graph, and these two items here are actually one in the same. However, they're displayed in two different ways. Now, what I'm getting at is there are two ways in which we can display data. So going to a more concrete example, say we've got the weather forecast. If we type into Google Brighton SA, what Google will present us with is a graph of the weather forecast over the next few days. Now this one is quite a few days old, but notice when we look at this graph on the left, we can instantly get the information that we're after, which is what the weather will be like. But if we look on the information to the right, we're presented with code. So this is sort of like a mathematical model, but it's used in a computer programming language. Now, what we're going to do today is we're going to have a look at converting a linear equation here. So this equation y equals x over 2 plus 3. We're going to look at how we can write this in a graphical model. So how we can create a graph from an equation. So that brings us to Learning Intention 3, Equation of a Line. Now going back, consider the equation of a line. We can write it in a form called y equals mx plus c. Now, last lesson in Learning Intention 2, we learned that this m corresponds to something called the gradient. But there are two, or there's at least one other feature here, and then there's the y and the x. Well, each of these components in the equation has a particular function in how it determines how the line looks. So what we've got is the x and the y. Let's just fix that up so it's easier to read. The x and the y, they correspond to coordinates on the Cartesian plane. So recall that on a Cartesian plane, this horizontal axis is the x-axis, and the vertical axis here, this is the y-axis. So these x and y points, they correspond to the x-axis and the y-axis. Now m, remember that we spoke about m in Learning Intention 2 stands for gradient, or the slope. So this depicts the way in which, or the way in which the line itself is tilted. Now if I go across the Desmos, notice with the m, if I change the m, the line swings upwards and downwards. So I'll hit pause. For a positive version of m, or a positive value of m, the line goes upwards. So as x increases, the line increases in y value. Notice as the line swings negative, as the x values increase, the line becomes more negative in the y value. And then we're presented with this new term here, c, or also known as the y-intercept. So this c corresponds to where the graph crosses the y-axis. So we call that the y-intercept. And this is always going to be at 0, c. Now going across, back to Desmos, notice I'll fix m to a value of 1. So for every square we go across, we go up 1, across 1, up 1, across 1, up 1. Notice what happens when we vary the value of c. So as you can see, the line is swinging upwards and then downwards. So if I pause it when c is a positive value, so I'll fix it to 3, it's a nice integer. Look at where the line crosses the y-axis. So if I pause it at 3, it crosses at 3. If I bring it down to 2, it crosses at y equals 2. If I let it run down into the negatives, it's going to cross at a negative value. So if c equals negative 3, the line crosses at y equals negative 3. So the c, or the constant, is called the y-intercept. Now jumping into some graphing examples, consider y equals x minus 1. If we use the form y equals mx plus c, the value of m is going to be the coefficient in front of this x. Now notice that because it's simply x, there's an implied 1 in front of it. So in this case, m is going to be 1. Going across again, we've got the c. So the y-intercept, that is going to be at negative 1. So in this case, c equals negative 1, or the y-intercept equals negative 1. Now just quickly going back to the gradient, we've got 1, but we want it to be in the form of rise over run. So another way of writing this is I can simply say 1 over 1. So the gradient equals 1 over 1. So for every value we go up, we have to go 1 square across. And finally for c, the graph is going to cross at negative 1. So if I were to graph this, I'd find negative 1 over on my axis, y equals negative 1, which is here. And then the gradient, it's going to go, for every 1 I go up, I have to go across 1. So as I go up 1, I'm going to go across 1. As I go up 1, I'm going to go across 1. As I go up 1, I'm going to go across 1. So I've got a point here, 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 and I could keep going as such. Now, to draw this line, I'm going to get my ruler out. It's very important that whenever we're graphing, we use a ruler. If we don't use a ruler, our graphs will be filthily messy. Your teacher won't understand what you're doing and you'll get marked down. So, whenever you're doing a graph, use a ruler. Now I'm going to line the ruler up to get through all of those points. Then I'm going to start towards the bottom of the graph and draw the line all the way upwards, passing through y equals negative 1 and passing through all of those individual dots. Getting rid of the ruler, I'm now going to annotate my line. So I need to put arrowheads on. The reason I'm putting arrowheads on is because this is a line and not a line segment. A line segment terminates at 2 discrete points. A line goes from negative infinity all the way to positive infinity. These arrows indicate that the line stretches from negative infinity all the way up to positive infinity. It neither has a start nor an end. Now, to clear it all up, I need to put the equation on the line. So I'm going to write y equals x minus 1. So this was the original equation here. So this equation is the same as this line. Now, just annotating it a little bit more, remember, this is the y-intercept, and it is at 0, -1. 0 because the y-intercept is always at x equals 0, and -1 because that is our c here. And we could call this part here the x-intercept. Now we could work out the value of the x-intercept, but it's not necessary so long as we've got a line and we've got this equation of the line on top of it to show that this equation represents this line, then that should be enough. Now, I'm going to graph this second equation here. So I'll go down to a new piece of paper, and looking at this one, I'm going to ask, what is the gradient? Well, the gradient should be the m in y equals mx plus c. Notice again, what is the m? It is the -1. Remember, the 1 is implied. Now the question is, what is the c? Whoops. C is here, so c is +1. So we can write m equals -1, or it can be written as -1/1, and c equals +1. Now, graphing this particular line, I'm going to look for where y equals 1 on the y-axis because of this constant of +1. So y equals 1 is here. Just get a thicker pen here, and then notice the gradient. For every 1 we go down because there's a negative, we go across 1. So I'm going to go down 1, across 1, down 1, across 1, down 1, across 1. I'm going to mark each of those points as such, and I'm going to get my ruler out, because remember, we need a ruler every time we draw a graph. If we don't draw it neat, then we'll get marked down by our grumpy teacher. So drawing a line, going through all of those points we just marked, putting the arrowheads on to denote that the line goes to positive and negative infinity, and then writing the equation on the line itself. So we've got y equals -x plus 1. Notice that the line, as x increases, the y values decrease. That is because we've got a negative gradient. Negative because there's a negative number in place of the m. Now, just to complete everything up, our y-intercept is here, and it is equal to 0, negative or positive 1. So I don't need to put that positive there. So it's 0 and 1. That would be our y-intercept. Right, so what we've learned is in y equals mx plus c, the c is known as the constant, and it is a term without a factor of x involved. It dictates the point at which the graph intersects the y-axis, this being the y-axis here. Now, let's have a think. Can we graph some more difficult equations? Well, having a go at this, our form of y equals mx plus c. Whoops, color got wrong there. There we go. So, looking for our m, in this equation, it is 1 over 2, and our c is negative 3. So writing that out, m equals 1 over 2, c equals negative 3. I'm going to graph this. First I'll find negative 3 on the y-axis, which is here. And then remember, rise over the run. So for every value I rise, I have to go across 2. So let's go up 1, and then across 2. Up 1, and then across 2. Marking the points, and then grabbing the ruler. Remember guys, the ruler is very important. So it should be roughly 25 degrees, but I think because of the scaling of this paper and my computer screen, it's slightly off. So go for 26. Now I'm going to draw a line. And then mark the features, so the arrowheads. And then I must annotate. It is y equals 1 over 2, the gradient of 1 over 2, x minus 3. Now, next line, b, y equals 0.25x minus 4. What is the constant? The constant is negative 4. What is the gradient? 0.25. So I'm going to do this one in green. So firstly, I'm going to find negative 4 on the y-axis. That is here. And then I need to find what is m if the gradient is 0.25. So one way I could write it is m equals 0.25 equals 0.25 over 1, or I want to have these as integer numbers, so I don't want decimals, so I know this is roughly 1 over 4. So I'm going to multiply. I know if I multiply 0.25 by 4, I'm going to get a whole number of 1. So if I multiply both upstairs and downstairs by 4, I'll get 1 over 4. So that's my gradient. As I said, my constant was negative 4. So this means for every value I go up, I have to go across 4. So I'm going to go up and then across 4. Back up 1 and then across 4. Now marking those points. And then grabbing my ruler. Arrowheads, and then I'm going to annotate. So this is y equals 0.25x minus 4. Awesome. Now I'm going to do c on the same Cartesian plane here. So let's do c in, let's go, not purple, we've done purple, let's go dark blue. There we go. So y equals 2x plus 3. Identifying the gradient is m equals 2, which is the same as writing 2 over 1. And then the c is equal to positive 3. So I'm going to write c equals 3. Now to graph it, I'm going to look for y equals 3. So 1, 2, 3, right there. and then I'm going to use the gradient. So it's 2 over 1. So for every 2 I go up, I have to go across 1. Up 2, across 1. Up 2, across 1. Marking all of my points here, here, and here. And then getting my ruler. That looks pretty close. Drawing the line. Marking the arrowheads. And then writing the equation. So this line here refers to y equals 2x plus 3. So there we go, we plotted A, B, and C. Now let's do D, E, and F. So D, notice that the form is slightly changed. The equation is written as y equals 2 minus 2x over 3. Now this isn't in slope-intercept form because the constant's been shifted over on the left and the gradient with its x term is over on the right here. So identifying the constant, it's actually there, and identifying the gradient is these parts here, so negative 2 over 3. So writing that out, c equals 2 and m is equal to negative 2 over 3. Now let's see if we can graph this. So finding 2 on the y-axis is up here, and then the gradient negative 2 over 3. So what that means is for every 2 we go down, because there's a negative, we go across 3. So I'll go down 2, then go across 3, go down 2, go across 3. Marking all of those points. Let's give it a spin. There we go. Drawing the line through all of the points we just marked. Bingo. So notice the line is going downwards again because we've got a negative gradient. Finish it off with the equation. We've got y equals 2 minus 2 over 3x. Now, next line. Firstly, identifying our m, we've got 2 over 3, and then identifying our c, so it's 6 over 3 as well. So this is a bit messy, so what I'm going to do is I'm going to change it a little bit. I'm going to get rid of this. I'm going to split up the numerators with a denominator. So we'll go negative 2 over 3x minus, actually no, that becomes a plus 6 over 3. So the reason why this became a plus here was, notice that there's a negative at the front here. We can actually write it like that. So this negative comes in and it multiplies with the 2 to become a negative 2x. And the negative comes in again to multiply with the negative 6 to make it a positive 6. And then simplifying a little bit further, this becomes a 2 over 3 over, or what is it? Simply becomes 6 divided by 3 is 2. So simplifying further, c equals 6 divided by 3, which is equal to 2. And then m is equal to negative 2 over 3. Now graphing this using a lovely green pen, we're going to look for positive 2, which is here. Then we're going to go negative 2 over 3. So down 2, across 3. Down 2, across 3. And what we have found is that the points seem to line up. Interesting. So what we've actually found is, although these equations, they look like they're in a different form, they actually represent the same linear graph. So writing out the equation, notice these two equations represent the same graph. Interesting. Now the final one is y plus x over 2x plus 3. Again, notice we're not in the form y equals mx plus c because we've got a term x hanging out with this y. So what I'm going to do is I'm going to take x from both sides of the equation. So go bang, take away x there, and take away x here. Bringing that all together, the negative x plus x cancels, so we've got simply y equals 2x minus x. That's simply x plus 3. Thus, m equals 1, or 1 over 1, and then c equals 3. Graphing this, I'm going to look for 3 on the y-axis. So grabbing my purple pen, 3 is over here. And then for every one we go up, we go 1 across. So up 1, across 1, up 1, across 1, up 1, and across 1. Marking all the points. Here, here, and here. And then grabbing the ruler. Finishing it off with the equation, y equals, let's do the original equation. So we could say x, or y plus x, equals 2x plus 3, or we could also write this form down here, y equals x plus 3. So either would be permissible, either the original question form or the slope-intercept form that we changed it to. Now there's two more cases that we need to look at. Those are the vertical and the horizontal lines. So remember in graphing with, or remember when working with the gradient with slope dude told us, or he taught us that for a horizontal line, the gradient is equal to 0. So remember the 0 fun. As x changes, there's 0 change in y. So what we're going to expect is something of the form y equals c. The reason it's y equals c is we've got a gradient of 0. So recall, y equals mx plus c. Because gradient is 0, m equals 0, y equals 0, x plus c. Anything multiplied by 0 is nothing. So it simply simplifies down to y equals c. Thus, y equals c. Next one is the vertical line. So notice, slope dude told us that for a vertical line, the slope or the gradient is undefined. So it would be something like y equals infinity times x plus the constant. Now notice that it doesn't matter however big this is here, it's never going to overcome this infinity, and whatever value we have for x, this is just going to be humongous. So this isn't actually an intuitive way to write the form. Instead, what we can write is x equals n being the point where we intercept the x-axis. So we call that the x-intercept. Firstly, we learn how to understand and interpret each member in a two-variable linear equation. Then we learned how to sketch linear equations in slope-intercept form. And then finally, we learned how to identify the equations for vertical and horizontal lines.